Hello everyone, JCE Connect. I welcome you all for this particular lecture. So in this particular lecture, I'll be deriving a equation for energy loss, that is expression for energy loss due to hydraulic jump. So in previous lecture, so we have been derived the expression for hydraulic jump, that is depth of hydraulic jump. So we have been derived. So because of the hydraulic jump, when the jump takes place from one section to the other section, that is from supercritical flow to this one, from supercritical flow to subcritical. When the flow takes from supercritical to subcritical, there will be a jump. So because of the jump, this one, there will be a large turbulence created at that particular region, and because of that there will be a energy loss EL, that is this one, energy loss. So the energy at section 1 will be E1 and energy at section 2 will be E2. This one, energy at section 2 will be E2, and the difference of these two energies is what we call as a energy loss. So we need to find out how much energy is being lost because of the hydraulic jump. So that is the expression for hydraulic uh, jump loss. So let us consider the loss of energy due to hydraulic jump. So here I am written, when the hydraulic jump takes place, a loss of energy due to eddies formation and turbulence occurs. This loss of energy is equal to the difference of specific energies at section 1 and 2. So same. So because of the hydraulic jump, the turbulence will be created here like this. The turbulence in this region the turbulence will be created. Then whatever the energy is being lost, that is EL, that is because of the difference of specific energies of E1 and E2. Now let us take loss of energy due to hydraulic jump. Then loss of energy due to hydraulic jump, which can be written as EL equal to E1 minus E2. So in this figure here, the energy at section 1 is E1 and energy at section 2 is E2. Up to here the energy will be E2. If you take energy here, this will be E2. Then the difference between E1 and E2 will be EL. So the energy at section 1 can be written as y1 plus v1 square by 2g, this is one term, minus y2 plus v2 square by 2g. Then you simplify this one, y1 minus y2, you get one term, plus 1 by 2g, you take it out. Then you substitute, as we know, v1 equal to q by y1 and v2 equal to q by y2. That is v1 equal to q by y1 and v2 equal to q by y2. Substitute here. When we substitute here, we get in place of v1 and v2, if we substitute, we get q square divided by y1 square, one term, minus q square divided by y2 square. Then y1 minus y2 plus take q square by 2g out. Then you simplify this one, you will get y2 square minus y1 square divided by y1 square into y2 square. Further, substituting, that is q square by g is equal to half y1 y2 into y1 plus y2. This we have got from the derivation of depth of hydraulic jump. This particular expression, it will be there in hydraulic jump expression. So from that, this is to be taken, this particular, from here it is. So in that, this one y1 plus y2, just recall back, 2 q square by g y1 y2, then q square by g will become half of this one, okay. Then simplify this one, just substitute this value above, then we get energy loss is equal to y1 minus y2 plus half into bracket half y1 y2 bracket y1 plus y2 then another term we get y2 square minus y1 square whole divided by y1 square y2 square. Then further you simplify it, just you go on simplifying, you'll get y1 minus y2 plus, when you simplify that by it, you will get y1 plus y2 one term, then we'll get y2 square minus y1 square divided by 4 y1 y2, okay. This you get. Further if you take simplify, you will take y2 minus y1 out, take y2 minus y1 out, you will get minus 1 plus y1 plus y2 one term, then y2 plus y1 divided by 4y1 y2. Just you go on simplifying this one. So this can be written as this one, this can be written as y1 plus y2 one term and y2 minus, sorry, y1 a plus b a minus b, y1 like this. Further simplify this one. Then EL you get y2 minus y1 into bracket y1 square plus y2 square minus 2y1 y2. If you simplify this one, you will get 4y1 y2, then y2 minus y1 one term, then this will be a minus b bracket square, that is y2 minus y1 whole square divided by 4y1 y2. Then if you further simplify, you will get y2 minus y1 divided by 4y1 y2. This is the expression for energy loss. This is the expression for energy loss in a channel. So this is very important expression for the examination point of view. Many a times the question will be asked, derive an expression for energy loss due to hydraulic jump, that is y2 minus y1 whole cube divided by 4y1 into y2. Then the height of jump will become height of jump. Many times in a problem the question will be asked, calculate the height of jump. Then the height of jump will be y2 minus y1 is the height of jump. Then what is the length of jump? Length of jump. Then the length of hydraulic jump will be, LJ will be taken generally 5 to 7 times of height of jump. This is thumb rule. So length of hydraulic jump, which is defined as, that is length of hydraulic jump, if you define, which is defined as the length between, it is the length between the two sections, length between the two sections is the length between the two sections where one section, here this one, you see this one, the length between the two sections where one section is taken before the hydraulic jump and another section is taken immediately after the hydraulic jump. For a rectangular channel, from experiments it has been found that this length of jump is equals to 5 to 7 times of height of jump. So it is the length between the two sections. One section is taken just before the jump and after the second section is taken just immediately after the jump, and it is experimentally found that the length of jump should be equal to 5 to 7 times the height of the jump. Okay. So these two derivations are very, very important for the examination of point of view. So please practice these derivations. So in next lecture we will be solving the problems on the hydraulic jump. I hope you understood these two derivations. So practice these derivations and try to understand. Thank you.